Hello friends, welcome to another video. So in this video we are going to look at the 2025 MIT Integration B semifinals question, which is the integral from 0 to infinity of x to the 1/3 divided by 1 plus x squared dx. So let's start off by doing a very simple use up here, right? So we can let u to equal to x squared. So here, if u is equal to x squared, then we have x here to be equal to u raised to the power 1/2. That is by taking the square root on both sides. Here the limits will not actually change. When x is equal to 0, u is going to be 0. When x is equal to infinity, u is going to be infinity, right? So we can find an expression for dx, which is 1/2 u raised to the power negative 1/2 du. So that is an expression for dx, and now we can take our integral here from the x world into the u world. So our integral is going to be I is going to be the integral from 0 to infinity of x raised to the power 1/3. So x here is u raised to the power 1/2, but it's raised to the power 1/3 divided by 1 plus x squared is u times dx. dx is 1 over 2 u raised to the power negative 1 over 2 du. Cool. Now 1/2 is a constant, that one goes in front. The integral from 0 to infinity of u raised to the power 1/6 divided by 1 plus u times u raised to the power negative 1/2 du. So I is going to be 1/2 the integral from 0 to infinity of 1 over 6 minus 1 over 2. You can do that here. I don't know what it is. That's 6. Here is 1 minus 3, and that is negative 2 over 6, and that is called negative 1 over 3. My bad. So u is going to be raised to the power negative 1 over 3 in the end over 1 plus u du. And that is 1/2 the integral from 0 to infinity of u raised to the power 2 over 3 minus 1 all over 1 plus u raised to the power. Here 1 plus u is raised to the power 1, but permit me to write it as 2 over 3 plus 1 over 3 because the two of them will sum to 1 and then the u. And why I'm doing this is because I'm going to compare this one to the beta function. The beta function of m and n is the same as the integral from 0 to infinity of x raised to the power m minus 1 divided by 1 plus x raised to the power m plus n dx. So if we look at this, our integral can now be compared to the beta function, right? And using the gamma representation of the beta function, this is the same as the integral from, I'm sorry about that, this is gamma of m, gamma of n divided by gamma of the sum m plus n, right? And now this our integral I is comparing that to this beta function. That is going to be 1/2 the beta of 2/3 and then 1/3. Cool. Now using the gamma representation of the beta function, that is 1/2 the gamma of 2/3. So I can write gamma of 1/3, gamma of 2/3 divided by gamma of the sum 1/3 plus 2/3, and that is equals to 1/2 gamma of 1/3. Gamma of 2/3, I can write that one as 1 minus 1 over 3 divided by gamma of the sum is 1. And gamma of 1 is 1 because gamma of 1 is 1 minus 1 factorial, which is 0 factorial, which is 1. So our integral just reduces to 1/2 gamma of 1/3 times gamma of 1 minus 1/3. Cool result. Now we are going to use a formula called the Euler's reflection formula. Euler's reflection formula, or some people just call it the reflection formula in short. So the Euler's reflection formula says that if we have gamma of z times gamma of 1 minus z, this one can be written as pi all over sine of pi z, or pi times cosecant of pi z, right? So this is the Euler's reflection formula. If we have gamma of z and 1 minus z, that can be expressed like this. So our integral I is going to be 1/2 the gamma of 1/3 and the gamma of 1 minus 1/3. So comparing this integral to comparing what our integral has been reduced to this one, you can see that z is going to be equal to pi over 3. Z is going to be 1 over 3, and that is going to be pi all over sine of pi times z. So pi times z here is 1 over 3. And that is equal to pi over sine of pi over 3. I'm forgetting something. There's 1/2 here. And there is 1/2 here. So this is 1/2, 1 over 2. Sorry about that. So that is going to be pi all over 1/2 sine pi over 3 is sine of 60, and that is equals to square root of 3 over 2. And these ones will cancel, and that is left with 2 over pi over the square root of 3. So that is how our integral can be solved. So this is our integral, the integral from 0 to infinity of the third root of x over 1 plus x squared dx. This one evaluates nicely to pi over the square root of 3. Courtesy the beta function, the gamma representation of the beta function, and then the Euler's reflection formula. So our answer is pi over the square root of 3. If you find this helpful, make sure to give me a thumbs up. Subscribe to my channel for more content from Calculus Diaries. I thank you so much for watching this video, and I'll see you in the next one. Bye bye.